kolejnych prezentujących z Politechniki Poznańskiej. Maciej Falbogowski, Zuzanna Trafas i Adam Wojciechowski. Zapraszam do prezentacji.
Tak, jestem.
Widać Panią, słychać, także może Pani spokojnie udostępnić ekran.
Super, już udostępniam prezentację. Okay, hi everyone. I'm going to present in English also. My name is Zuzanna Trafas, and today I want to give you a really short overview of our bachelor's thesis focused on creating a library for counterfactual explanations of machine learning predictions. With the rapid growth of artificial intelligence and deep learning, in particular, the models are getting more and more complex. The field of explainable AI tackles this problem and helps explain the model's prediction, making it easier to understand the reasoning behind them. We decided to focus on a specific part of explainable AI, which is counterfactual explanations. But what does this hard and long word counterfactual really mean? Well, counterfactual explanations is like answering a question. What do I have to change in order to tweak model's prediction? For example, if you are applying for a loan and got rejected by an AI decision, you might want to know what the reason was. A counterfactual explanations might show that if you earned 10,000 more, your loan would be approved. For our library, we chose to implement ECE method, which creates an ensemble of counterfactual explanations and selects a set of best of them, taking into account how close they are to the original example and how different from each other they are. Additionally, we implemented Temat, which creates perturbations with a neural network trained to generate a counterfactual, and Codex, which uses gradient descent to find the decision boundary. Both these methods can be used with the ensemble, and other counterfactual methods could also be easily adapted to the library. Now, let's see how it works in practice. Here we can see our data. We are a very happy 27-year-old person earning $100,000 a year and living with our spouse. But our plans for buying a house get ruined when our loan application gets rejected. We want to know what we can change in order to have it approved. But now, the counterfactual explanation we get doesn't really help us at all. Not only does it tell us to rejuvenate ourselves and be -5 years old, but also to divorce our spouse. That's not good enough for us. That's why, to tackle this problem, our library allows defining constraints on the data. The freeze constraint disables changing value of a given parameter, like gender or the marital status. Monotonicity allows values to change only in one direction. For example, we can set the age only to increase, as we cannot really get any younger. Nominal constraint helps keep the nominal variables in a discrete space. The implementation was done using Python and some libraries shown on the slide. The counterfactual, or set of counterfactuals that we create, is a pandas data frame, shown on the bottom of the slide, showing original sample value, counterfactual value, and what the change was, together with which constraint was used. But we didn't stop there. As an addition to creating the library, we decided to do a little research and assess how this constraint affects the quality of created counterfactuals. For this, we created 4 metrics shown on this slide, allowing us to check and compare how actionable the explanations we generate are. The results showed that the declines in the metrics we chose were insignificant and mostly depended on the method used for counterfactual generation, which highlights just how important it is to take constraints into account when designing a new counterfactual method. Thank you for your attention despite this late hour, and I highly encourage you to check our GitHub repository or the paper based on our work, which was presented at PPRI conference for more information on counterfactual explanations and how you can get your loan approved. Thank you very much.
Bardzo dziękuję, super praca. Gratuluję wygranej.